Hi, my name is Stephen Edbrook, and I work with Validyne Engineering. Today I'll be going over the basics of pressure sensors and pressure measurement. This video will teach you what pressure is and how to measure it, the basic terminology you'll need to know, what the different type of sensors are, and how to determine the accuracy of the sensor, and finally, I'll be finishing up by going over the different technologies available and what their strengths and weaknesses are. So what is a pressure sensor? First, let's go over what pressure is. Pressure is the force applied to an area. Pressure is all around us. If you're on Earth around sea level, then you currently have around 14.7 psi pushing against your body right now. You can measure this through a pressure sensor. A pressure sensor measures a gas or liquid pressure and converts the value into an electrical signal. With the signal, you can know how much pressure is being applied to your device. Sensors are used everywhere. They're in roads, machines, vehicles, weapons, and laboratories. You can also use pressure sensors to find other physical properties such as flow, speed, water level, and altitude. Pressure measurement has some terminology that's vital to know if you're looking to measure pressure and need a sensor. First, a pressure sensor is a device that produces a signal proportional to the change in pressure. Now this is often confused with our next term, which is a pressure transducer or pressure transmitter. The main key difference is that a pressure sensor doesn't have electronics to process the signal and provide an amplified output. If you purchase a pressure sensor, you will most likely need to purchase some form of compatible signal conditioning, whereas if you purchase a pressure transducer, it'll be built in. Now there are three main types of measuring pressure that you need to know about: gauge, absolute, and differential. A gauge pressure is a pressure measured relative to ambient pressure. Absolute is a pressure measured relative to the vacuum of space. And differential is the pressure difference between two separate pressures. I will go over these more in the next slide. The next term to know is a line pressure. A line pressure is the ambient pressure applied to both sides of a differential sensor. For example, if I needed to measure the pressure difference between two pipes, and one pipe had 100 psi of pressure, and the other pipe had 110 psi of pressure, the line pressure would be the 100 psi that the sensor experienced on both sides. The full scale of a sensor is the difference between the maximum pressure and the zero pressure. If a pressure sensor measured up to 100 psi, the full scale would be 100 psi. Accuracy is the maximum deviation from a best fit straight line, and I'll also be going over this later in the video. Drift is the gradual output change from the calibrated state over time. All sensors have some drift, and if you're going to be measuring the same pressure over the course of years, knowing the drift of the sensor will be very important. Resolution is the smallest difference between an output that can be meaningfully distinguished. Practically, what this means is the number of readings per second that the sensor will be able to record without error. And last is the overpressure, which is the maximum pressure that can be applied to a unit without damaging the sensor. Now that we've learned the terms, let's dive into the differences between the types of pressure. A gauge pressure is the most common form of pressure referenced, and it stands for the pressure made in a positive direction when compared to ambient pressure, which again is around 14.7 psi at sea level. For example, if you're measuring the pressure of your car tire, you're making a gauge measurement. You don't need to care what the pressure of your tire would be in the vacuum of space. You only care about what the pressure is compared to the pressure of the air around the tire. Now, an absolute pressure is relative to zero pressure, or the vacuum of space. This type of measurement is important when you need to compare pressure at multiple altitudes. Aerospace engineering commonly uses absolute pressures because the air pressure at 30,000 feet is very different than the air pressure at sea level, and the measurement needs to be consistent regardless of altitude. Next is differential pressure, which measures the difference between two pressures. So if we go back to our previous example, if you have a pressure at 110 psi and 100 psi, the full scale of the differential pressure, also known as the delta P, would be 10 psi. The last sensor we will be discussing is a vacuum pressure sensor. A vacuum pressure sensor is used to measure vacuums. The sensor measures the negative pressure from any starting point you prefer. These are the least commonly used. As we discussed in the terms, the accuracy of a sensor is measured using the best fit straight line method. But what does that mean? The best fit straight line method measures the pressure of multiple points and the output is recorded. We then draw a best fit straight line that most accurately represents the median of the data points. The points are then measured for the deviation from the best fit straight line. The level of deviation allowed is the accuracy of the unit. For example, if a sensor has an accuracy of 0.1% full scale, then the maximum that any of the recorded pressure points can deviate from the best fit straight line is 0.1%. Knowing the accuracy is very important if you're looking to make precise measurements, and it's important to know how the calibration is made for your brand of sensor. Pressure measurement has been studied since the 1600s, with Galileo first discovering the phenomenon while trying to pump water with a syringe. We have made amazing achievements since then. In modern times, there are 6 main technologies that we use to measure pressure. I'm going to briefly go over the 6 pressure sensor technologies and what their pros and cons are. First up is the potentiometric pressure sensor. These work using a bird-on tube, capsule, or bellow to drive a wipe on a resistive element. The advantage of this technology is that it's an inexpensive sensor to use when you don't need your measurements to be accurate. As you can imagine, the disadvantage is that the measurements are very inaccurate and mostly only viable for coarse measurements, like the oil pressure gauge on your dashboard. The next sensor is an inductive pressure sensor. This works using the LVDT of a moving core to vary the inductive coupling between the transformer primary and secondary. The advantages of these are that the sensor can withstand harsh environmental conditions and can last a long time, but are known for having a very low frequency response and requiring a filter if you need a DC output. These are one of the least commonly used sensors. A capacitive sensor measures pressure by having the applied pressure cause the diaphragm to deflect and causing the capacitance to change. You can measure this using the formula C equals mu A divided by D, where mu represents the material between the plates, A represents the area of the plates, and D represents the space between the plates. Capacitive sensors are known for their accuracy and durability while struggling with their sensitivity to temperature and capacitance. They also have a very low frequency response and are generally larger in size. Piezoelectric pressure sensors work by converting stress into an electrical potential and vice versa. The 2 main types of piezoelectric sensors are ones made with a ceramic sensing plate and ones made with quartz. A quartz piezoelectric sensor will give you the most accurate pressure measurement you can find, but will cost you up to tens of thousands of dollars. The advantage that both types of piezoelectric sensors share is that they can be small, have a high frequency response, and have a low displacement. The disadvantage is that their long-term stability can be shaky, and it's sensitive to temperature. Next up is the strain gauge pressure sensor. These are one of the most common types of sensor and function by measuring the resistance change of silicon when stress is applied. This is called the piezoresistive effect. The advantages are fast response time, easy to manage temperature compensation, and a high accuracy. The disadvantages are they are unable to provide lower pressure ranges, they have a low level outputs, and they can suffer from long-term drift problems. Now, the last type of technology that we'll be talking about today is variable reluctance pressure sensors. This is the style that Validyne Engineering specializes in, so as you would imagine, it's my favorite. The sensor works by creating a magnetic circuit, and when pressure is applied to the sensing diaphragm, the magnetic field is changed. We are able to pick up the displacement of the magnetic circuit and convert it into a signal output. Some major advantages are that the sensor can be used to measure both liquids and gases. The sensors are made of stainless steel, so they're durable and resistant to high temperatures and harsh corrosive or oxidizing medias. They also provide high outputs at all pressure ranges. That allows variable reluctance technologies to measure the lowest pressure ranges of any sensor. An advantage with this technology that is unique to Validyne is the ability to replace the diaphragm of the unit in order to change the pressure range or repair the unit. The disadvantages of variable reluctance sensors are a relatively larger size and the need for signal amplification. And that about covers the basics of pressure transducers. Thank you for watching, and if you'd like to learn more, feel free to email me at sales@validyne.com or give us a call at 818-886-8488. We have a highly informed staff that's able to help. We'll be making more informative videos on pressure measurement and how to solve more specific pressure-related problems, so if you're interested in learning more, please subscribe to our channel and hit the bell. Be sure to like this video if you enjoyed the content, and I'll see you next time. Thanks for watching.